probability measures how likely it is for an event to occur. The probability of an impossible event is 0, or we could say 0%. The probability of a certain event is 1. So if it's never going to happen, the probability is 0, and if it is certain to happen, the probability is 1 or 100%. Otherwise, the probability of an event is a number between 0 and 1, or we could write it as a percent between 0% and 100%. When you gather data from observations, you can calculate what's called an experimental probability. Experimental probability is the number of times the event occurs out of the total number of trials. So, for example, of the 60 vehicles in a teacher's parking lot today, 15 are pickup trucks. What is the experimental probability that a vehicle in the lot is a pickup truck? So the probability would be 15 pickup trucks out of 60 vehicles total, which we could write as 1/4, or we could write it as 25%. Either is correct. So we either want to simplify our fraction or we want to write it as a percent. A softball player got a hit in 20 of her last 50 at-bats. So what is the experimental probability that she will get a hit in her next at-bat? So the experimental probability, since she hit 20 of her last 50, would be 20 out of 50. Or we write it as 2/5, or we could write 40%. So that's when we do what's called an experimental probability. So the set of all possible outcomes to an experiment is called the sample space. And when each outcome in a sample space has the same chance of occurring, the outcomes are equally likely outcomes. So then comes a different type of probability, which was probably the one we're used to, which is what's called theoretical probability. If a sample space has n equally likely outcomes and an event A occurs in m of these outcomes, the theoretical probability would be m over m. So it's like the probability of what is what we want to happen out of the total number of outcomes that will happen. So it's the number of ways that we want of a favorable outcome. Sometimes we write it like that. The number of favorable outcomes out of the total number of ways. Okay, so we could look at these examples. What is the probability of each event? So we're talking about theoretical probability. So what's the probability of getting a 5 on one roll of a standard number cube? So the probability of getting a 5, let's see, on a standard number cube, there's 6 sides and there's 1 through 6. So the probability of getting a 5 would just be there's 1 5 out of 6 total possibilities. So the favorable outcome would be to get the 5. So there's one way to do that. And then there's 6 ways to roll the die. So 1 out of 6, or let's see, 1 out of 6 would be, we could write it as about 17%. So what's the probability of getting a sum of 5 on one roll of 2 standard number cubes? So let's say we're rolling 2 standard number cubes, 1 through 6 on each one. What's the probability of getting a sum of 5? So we have to think of the possibilities here. So if we make a chart, this might help. There's 6, there's the first die, number cube, we'll call it. And then here's the other one. Okay, so if we roll it, the sum would look like this. Sum of 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5, and 1 plus 6. And then this would be 3, 4, 5, 6, 7, 8. 3 plus 1 is 4, 3 plus 2 is 5, and it goes down like this. 4 plus 1 is 5, 6, 7, 8, 9, 10. These are the sums of the 2 die being rolled. The 2 number cubes. 5 plus 1 is 6, 5 plus 2 is 7, 5 plus 2 is 8, 9, 10, 11. 6 plus 1 is 7, 8, 9, 10, 11, 12. So I'm just writing down all the possibilities here. And I see that there are four possible ways to get a sum of 5. You could either have a 1 plus 4, a 2 plus 3, a 3 plus 2, a 4 plus 2, or a 5 plus 1 would give, 1 plus 4, 2 plus 3, 3 plus 2, 4 plus 1 would give you the only possibilities of sum of 5. So that would be 4 favorable outcomes out of how many total? It would be 6. If we count the 6 by 6 square we have here, it would be 36 possible outcomes. So that would be 1 out of 9, which is approximately 11%. And then the last one says getting a sum that is an odd number on one roll of 2 standard number cubes. So if you rolled both cubes once, what is the probability of getting a sum that is odd? So if we look at our chart, we see that, let's see, two threes, 4 5s. So that's 2 plus 4 is 6. 1, 7, 8, 9, 10, 11, 12. If we add the 7s, 13, 14, 15, 16, 17, 18. So it looks like half will be odd and half will be even. So 18 favorable outcomes out of 36 total possibilities, which is 1/2 or 50%. Okay? And then lastly, we'll talk about cards. What is the probability of each event? Being dealt exactly 2 7s in a 5-card hand from a standard 52 card deck. Okay, so in a standard 52 card deck, we have 4 7s. 4 7s and out of the 52. That's what we have. So we want to be dealt exactly 2. So it gets a little complicated here. We have to talk about combinations, because if you're being dealt a 5-card hand, then it doesn't matter the order in which you are dealt the cards. So how many ways can I be dealt a 5-card hand from a 52 card deck? So let's add that to the side. How many ways? So a combination of 52 choosing 5 would be how many ways you can be dealt a 5-card hand. 52 choosing 5, because out of the 52 cards, you're selecting 5 of them where the order does not matter. That's what we talked about yesterday with combinations. Okay, and then I want to know how many ways can I be dealt exactly 2 7s? Well, exactly 2 7s. So I have to figure out, okay, what am I selecting from? I want to be dealt a 7. So there are 4 7s, and I want to be dealt 2 out of those 4 7s. So the number of ways I can be dealt exactly 2 7s would be a combination of 4 choosing 2. So that's the number of ways you can be dealt 2 7s from 4 7s. And then what's going to happen is you are being dealt 3 other cards. Besides those 2 7s, you're being dealt 3 other cards. So after we take out those 2 7s that you have already gotten, just kidding, the 4 7s that we don't want, because you want 2 7s and then you want 3 of something else. So we're going to take out those 4 7s from 52, and that leaves 48. So now we have a combination of 48. We're selecting from 48 of the other cards, not the 7s, 48 non-7s. So non-7s. And we want to select 3 because we want 3 that are not 7. So this is the number of ways you can be dealt 3 other cards, not 7s. So now we have to talk about probability. So the number of ways I can be dealt 2 7s and 3 other cards, we want to multiply those together. Remember, that's fundamental counting principle. We want this and this to happen. So we want to multiply those number of ways. So I'm going to do the combination of 4 choosing 2, and that's how many ways I can be dealt 4 7s, times the combination of 48 choosing 3. That's how many ways I could be dealt 3 other cards. So combination of 4 choosing 2 times the combination of 48 choosing 3 is how many ways I can be dealt 2 7s, exactly 2 7s, and 3 other cards from a standard 52 card deck. That is my number of favorable outcomes, and this is probability. So it's out of the total number of possibilities. So the total number of possibilities to be dealt a 5-card hand would just be the combination of 52 choosing 5. So we're going to go to our calculator now and get this number. So we're going to do, I'm going to make a fraction. So I'm going to do combination of 4 choosing 2. That's 4 sevens. Out of 4 sevens, I'm choosing 2. Times. And then I'm going to do another combination of 48 choosing 3. Now that's out of the other 48 cards, I want to select 3 of them. The order does not matter. And that's the number of favorable outcomes. Out of the total number of possibilities, which is, I want a combination of 52 choosing 5. And it gives me, I'm going to round 0.0399. That's what I'm going to say. 0.0399, which is about 4%. All right, and then lastly, I want to know what is the probability of being dealt 5 hearts in a 5-card hand. Okay, so how can I be dealt 5 hearts? Well, first I have to think, okay, the favorable outcome would be I would be dealt a heart. So how many hearts are there? There are 13 hearts in a standard card deck. 13 hearts, 13 spades, 13 clubs, 13 diamonds. So the combination of 13 choosing 5, not 5, yes, 5, is the number of ways you can be dealt 5 hearts. And then, so that's going to be my favorable outcome. My favorable outcome is I want to be dealt all 5 hearts. So my numerator for this probability is going to be a combination of 13 choosing 5. Out of the total number of possibilities, and we've already talked about that, the total number of possibilities, total number of ways I can be dealt 5 cards from a 52 card deck would be a combination of 52 choosing 5. So this is it. This is my probability. So I'm going to go to my calculator and I'm going to do, I'm going to put in a fraction. And I'm in a numerator. In my numerator, I'm going to do a combination of 13 choosing 5. Remember, out of the 13 hearts, I want 5 hearts. That's a favorable outcome. And then out of the total number of possibilities, which is a combination of 52 choosing 5. That's how many ways I can be dealt 5 cards in general. Total number of possibilities. And I get this. So this is 4.952 times 10 to the negative 4th. So 4.952 times 10 to the negative 4th. 1, 2, 3, 4. So that would be 0.0005, which is 0.05%.